Good morning, good afternoon, good evening, whichever it is for you, wherever you are watching this presentation from. I'm Dr. Matt Ware from the Florida State University Marine Turtle Group, and on behalf of my co-authors and I, thank you for listening in to this presentation of some of our work over the last 2 years, investigating the exposure and consequences of wave washover for loggerhead sea turtle nests in the northern Gulf of Mexico. In addition to your attendance, I'd like to thank the Sea Turtle Grants Program for funding this work, all of the volunteers on St. George Island and throughout the Northern Gulf who put in hours of tiresome work to conserve these animals, as well as the symposium organizers for all of their hard work putting together this event despite the COVID challenges. So what's the big deal with waves? Why do we care if loggerhead nests get a little wet? To start, sea turtle embryos require a relatively narrow range of conditions to develop properly, including temperature, salinity, and gas exchange with the surrounding environment. Wave exposure, as well as sustained groundwater inundation or heavy rainfall, can significantly alter these incubation conditions. On the far end of the spectrum, wave-induced erosion can wash the nest out to sea, where the developing embryos can drown in the surf. Even if the nest remains in place, prolonged wave exposure can result in hypoxia, increased salinity, and cooler temperatures, which may affect embryonic mortality and hatchling locomotor function, size, and sex ratios. To top it off, this threat is increasing. Coastal squeeze from upland development, shoreline armoring, and sea level rise is reducing the available beach area for many nesting sites around the world. In addition to being squeezed into the smaller space, changes in hurricane frequency, intensity, and timing as a result of climate change will affect a greater percentage of nests. This is particularly a problem for small, genetically distinct populations, such as that in the northern Gulf of Mexico. The northern Gulf of Mexico Loggerhead Recovery Unit is among the smallest in the U.S., with only several hundred adults. Significant clutch losses for so few individuals will greatly delay the population's recovery. Now, it's not all doom and gloom. Sea turtles have several natural defenses against the threat of wave exposure. Nesting females lay multiple clutches within a nesting season, place these clutches in different locations, and use environmental cues such as beach elevation, slope, and distance from the water when selecting these locations in an effort to maximize productivity. Egg production is also not a small-scale effort. In her lifetime, a loggerhead female may lay tens of thousands of eggs. Some losses are to be expected. And when the clutches do get washed over, the event is not inherently lethal. The embryos can tolerate a certain degree of exposure without significant detriment. In some cases, the exposure may be beneficial in reducing incubation temperatures and increasing male hatchling production at otherwise heavily female-dominant nesting beaches. Lots of females in the population is great for recovery, as sea turtles are not exactly monogamous, but you still need enough males to do the job. Given these defenses, and that some losses are natural and to be expected, is wave exposure a threat which requires our intervention? This is a question the general public, sea turtle volunteers, researchers, and state and federal managers ask and get asked all the time. There is still a lot we don't know, and when working with endangered species, we certainly want to be cautious about not doing additional harm in pursuit of something well-intentioned. For example, relocating a nest closer to the dune toe, a common wave exposure reduction strategy, may increase the risk of predation, desiccation, hyperthermia, and disorientation for the developing embryos and hatchlings compared to their original nest site, and you may lose embryos in the movement process itself, all without a guarantee that the nest will be lost in the first place. So there are several questions that need to be answered before we intervene. Our to-do list. Where is wave exposure impacting the most nests? At what frequency or duration does wave exposure cause significant harm? Do these exposure thresholds vary with the developmental stage of the embryo? How does this tolerance, or lack thereof, vary by species and population? What are the benefits of non-lethal levels of wave exposure? Would relocating nests introduce other threats which may cause as much or greater impact than wave exposure? What other options are available besides relocation? This project has taken a crack at the first 3 questions. Before we can even think about addressing the threat of wave exposure, we need to know where it is occurring. Each morning, volunteer and professional crews walk the beaches in the northern Gulf of Mexico to locate and collect data on sea turtle nesting. Among the data these crews collect are the GPS location of the nest, any wave washover or other disturbances during the nest's incubation, and how many hatchlings ultimately come out. Using this data from 40 nesting beaches across the Florida Panhandle, we were able to map out the distribution of nesting frequency. Wave height, period, and tide height data from the same time period were fed into a run-up model to map up areas of high wave exposure. Finally, these two data sets were combined to prioritize nesting beaches by the overlap between wave exposure and nesting frequency. For a full breakdown, I recommend that you check out the paper published open access last year in Remote Sensing. Loggerhead nesting was concentrated in the eastern panhandle. The top 5 beaches by nesting frequency were St. George Island, Little St. George Island, the St. Joseph Peninsula and State Park, and the St. Vincent National Wildlife Refuge. Together, these 5 beaches account for 62% of nesting in the Panhandle. From 2016 to 2019, almost 6,800 nests were available for analysis. Of these, 42% reported some degree of wave washover, including 18% which reported complete or partial erosion. For those nests washed over but still in place, hatching success, the number of hatched eggs divided by the total clutch size, declined to 27% compared to 78% for undisturbed nests. Emergent success, the number of hatchlings which actually made it out of the nest, showed a similar decline. Wave exposure was generally concentrated in the eastern panhandle as well, but showed more spatial variability than nesting frequency. The wave run-up model performed well as it accurately identified the washover state of 89% of the loggerhead nests. Based on this model, nests had a low day-to-day risk of exposure, as only 12% of all total water level observations reached nest locations, which are typically laid above the daily high tide line. However, storm conditions are a different story. Tropical storms and hurricanes impacted 50% of the beach area on average, including 34% of nesting locations. When ranked by wave exposure and nesting frequency, the top 5 beaches were all in the eastern panhandle. The St. Joseph Peninsula State Park took the top spot, followed by the St. Joseph Peninsula, St. George Island, Cape San Blas, and Little St. George Island. Interestingly, though all 5 beaches are in the top 25% with respect to nesting frequency, only the St. Joseph Peninsula State Park and Cape San Blas were also in the top 25% for the proportion of nesting exposed. St. George and Little St. George Islands were in the bottom 25% for exposure proportion. However, their high nesting frequencies compared to other beaches meant they still had significant counts of nests exposed, hence their placement in this list. This dichotomy in the proportion of exposed nests gets us to another question on our to-do list. What other options are available besides relocation? Places like St. George and Little St. George may be better candidates for habitat preservation as refugia rather than active relocation programs, given that there is still plenty of available, suitable nesting habitat, at least with respect to wave exposure. The other end of the spectrum, high nesting frequency and wave exposure, are prime beaches for addressing the other knowledge gaps highlighted in our to-do list. Now that we know where washover is most problematic, we moved on to the next 2 questions in our to-do list. At what frequency or duration does wave exposure cause significant harm? And do these thresholds vary with developmental stage of the embryo, species, or population? For this aspect, we focused on St. George Island over this past nesting season. As I mentioned earlier, St. George has the highest nesting frequency in the Northern Gulf, and it was ranked 3rd on our priority list. Plus, it's easily accessible and a beautiful place to work. What else could you want? We partnered with the St. George Island volunteer turtlers on a 2-pronged approach. First, the morning volunteers were to report all nesting locations, daily wave exposure, and hatchling production per their usual protocols. This would give us a larger sample size over a broader spatial scale, but it has a coarse temporal scale, as surveys are only done once a day. Second, a subset of 16 nests would receive hobo water level loggers. These loggers record hourly water depth measurements so we can investigate inundation duration, but at the cost of sample size. This was all based on previous work I conducted on the Fort Morgan Peninsula in Alabama between 2016 and 2018. See the papers here for more details. In 2021, 252 nests were laid on St. George Island between the 20th of May and 22nd of August. Of these, 230 were loggerhead and 22 were green turtle nests. 77% of the nests reported wave washover at any point during their incubation, including 42% which were completely or partially eroded, largely due to Tropical Storm Fred in mid-August. For comparison, only 17% of nests reported predation, primarily by ghost crabs, but one nest was predated by fire ants. When looking at hatching success as a function of wave washover frequency, non-disturbed nests had a mean hatching success of 90%. Hatching success declined to 40, 26, 2, and 0% as washover frequency increased from 1 to 4 events. Emergent success followed a similar pattern. The timing of this washover had little impact on hatchling production. There is a slight increase in hatching and emergent success if wave exposure occurred later during incubation, but the effect is minor. While investigating inundation duration, only 7 of the 16 hobo loggers deployed on St. George survived thanks to Tropical Storm Fred. To increase the sample size, I combined the St. George data with hobo data from loggerhead nests on the Fort Morgan Peninsula of Alabama from 2017 and 2018. The turtles are part of the same genetic subunit, and the deployments followed the same methodology. Combining these datasets bumped the sample size up to 28 nests. Even with this increase, there is a lot of variability in the data, but hatching success appears to decline to roughly 0 beyond 20 hours of cumulative inundation exposure. So where do we go from here? We demonstrated on which beaches wave exposure is most problematic for the Florida Panhandle, that hatchling production falls to basically 0 after 3 washover events or 20 hours of cumulative inundation, and that the timing of washover events has little impact. However, there is still a lot of variability in this data that is currently unaccounted for, likely due to interactions between the duration and proportion of the clutch exposed during each inundation event. So we need some more data to fill in these gaps. There are also still several questions on our to-do list, including variations in exposure thresholds by species and population, benefits of non-lethal exposure, and investigations into various management approaches for combating the wave exposure threat. Certainly plenty to keep us busy for a while. Thank you all for your time today. If you have any comments or questions about this work or the presentation, you can reach me by email at mw15w@my.fsu.edu. Enjoy the rest of the symposium.